Hello, dear listener. A grand salute to the depths of the ocean, and the rule of the glaciers to the extended polar winds had been given in the correct order before the maintenance of this piece. Whether you are ready to immerse yourself in the languor of summer nights, or you simply want to free yourself a little from the hustle and bustle of the modern world and relax with a quiet, captivating historical story, I am very, very happy that you joined me tonight. Now, is it usual to have a little introductory session among us? If you don't mind, is this volume reaching from all over the world? I would like to know that. Are you heroes from Turkey, or are you listening to me from another continent? And most importantly, what time of day is it for you right now? Perhaps while I am here experiencing the silence of the night, the sun is just setting or breaking. To refrain from leaving a comment and to connect with me. It's always a great pleasure that those who want to relax with these calm stories of history enthusiasts find these various elements and gather here. If you enjoy this calm, captivating storytelling from the past, do not hesitate to click that subscribe button. Even the next episode in the appearance of that little icon will never be shared. With your support, continuing these peaceful journeys becomes much easier. But now, let's allow all the stresses of the modern world we have reached and our daily worries to melt away. Imagine the calendars show the year 1914. The world is dancing on a tightrope in its Great War. The tensions that had long been accumulating among Europe's great powers were waiting like a volcano ready to erupt. Military strategists in each country were searching for new and destructive ways to gain superiority over the enemy, deliver unexpected blows, and turn the tide of war in their favor. While land and air forces were rapidly developing, competition at sea was also taking on a different dimension. It was precisely during this period that submarines, those massive metal fish that could be held underwater, were gradually beginning to appear on the stage of war. But let's pause here and clarify an important detail. Do not, of course, confuse these 1914 ancestors with today's nuclear-powered, incredibly comfortable, capable of staying underwater for weeks, and possessing incredible range. The submarines of those days were quite primitive, almost experimental machines that constantly struggled for survival, even in more temperate and known areas, leaving behind detailed accounts of survival in harsh and unexplored regions like the North Pole. So, what does this primitive label mean? The submarines used before 1914 and in the early years of the World War generally operated on diesel-electric systems. This working system was quite simple but brought with it limitless limitations. The submarine would move on the surface while its diesel engines, operating through screws, would propel it forward. These diesel engines not only moved the submarine but also charged the batteries that powered the electric motors to be used underwater. However, when they wanted to submerge, they had to shut down the diesel engines and switch to the electric motors running on batteries. This transition meant a change in the submarine's main power source, and the real problem started here: limited battery life. The battery technology of that era was laughably inadequate even compared to today's smartphone batteries. The submarine could only stay underwater for a few hours at most. When the batteries ran out, like an unplugged vacuum cleaner, the submarine would become as immobile as a stone, having to surface. Just imagine. Running out of energy at the most critical moment, perhaps trapped under ice. That was a disaster scenario in itself. It wasn't just the power systems. The whole structure and the shelter of the submarine also posed a great limitation. The submarines of this period were initially designed for shallow-depth operations. A depth of more than a few hundred feet posed a great risk. The steel alloys and engineering marvels to withstand the immense pressure of the oceans had not yet been discovered. The hulls of World War I submarines had no resistance against the challenges of the North Pole's thick and massive ice sheets or extreme water pressure. They were as good as tin cans. Their main purpose was to stealthily approach enemy ships, launch torpedoes, and patrol in temperate, known sea routes. Scenarios like gliding under the glaciers of the North Pole, navigating under constantly moving massive ice masses, or struggling with mechanical failures and freezing cold were not even considered by the designers of these divers. These vehicles were not built for polar exploration but for naval warfare, and they were completely unprepared for the future's harsh and destructive threats of polar geography. From a range perspective, the submarines of 1914 were also severely limited. Underwater visibility was almost zero. Their periscopes could only be used at close range and were almost useless in a foggy, dark, ice-covered environment like the North Pole. Their navigation systems were primitive. Magnetic compasses did not work reliably in polar regions, and satellite systems like GPS were not even dreamed of yet. For unexplored or inadequately mapped regions like the North Pole, maps either didn't exist or were extremely insufficient. Determining the submarine's depth and precise position was a complete nightmare for the crew. For an underwater vessel to proceed into the unknown, surrounded by ice in that region, was tantamount to suicide. Now, leaving aside the technological limitations of World War I submarines, let's abandon them to the arms of perhaps the most challenging and formidable enemy of that era, the North Pole itself. This is not just a region to look at. It is like a living, breathing beast, ready to swallow you whole. This white hell, where the most extreme conditions on Earth prevail, was a landscape full of traps for a submarine, especially a 1914 model submarine. First of all, ice. The North Pole means massive, moving ice masses, thick ice sheets, and ice mountains. These extended not only on the surface but also deep into the sea. World War I submarines were not designed to navigate under ice. Imagine encountering a sheer ice wall while moving through the water. The submarine's thin hull would crack like an eggshell. Even modern submarines require specially trained crews and highly advanced sonar systems for under-ice operations. For a 1914 submarine to dive blindly under ice was suicide. Colliding with an ice mass would cause irreparable damage to the hull, water would start leaking, and it would spell the end for the submarine. Furthermore, ice was not just a static obstacle. It was a dynamic structure constantly moving with winds and currents. Even a thin ice layer moving could entrap a submerged submarine. This meant complete loss of contact with the surface and zero ability to escape. The second great enemy was cold. The freezing cold of the North Pole brought air temperatures to sub-zero degrees and seawater to near freezing. Although the submarine was somewhat insulated from this extreme cold outside, the internal heating systems were extremely primitive and insufficient. The crew was constantly at risk of hypothermia. Machines and sensitive mechanisms also suffered from this cold. Metal parts expanded and contracted. Delicate mechanisms froze and became inoperable. Diesel engines could freeze. Electric battery performance dropped, and pumping systems could ice over. A valve freezing or a pipe bursting could directly affect the internal life support systems. Outside seawater icing over the submarine's hull could create layers of ice. This could render periscopes, ventilation hatches, and other external equipment unusable. Cold was a sinister enemy that directly threatened not only life but also human survival. The third and perhaps most demoralizing enemy was darkness. For a large part of the year, especially in winter months, the North Pole would be surrendered to polar night. The sun would not rise above the horizon for weeks, even months. This meant a complete deprivation of natural light. Although there were artificial light sources inside the submarine, this did little to alleviate the deterioration on crew's psychology. The severance of visual contact with the outside world, the feeling of imprisonment could trigger panic attacks, impair judgment, and lead to a general breakdown in morale, unfolding in an endless, dark void. Additionally, darkness made navigation and any external observation impossible. Even during the day, the density of ice and fog could reduce visibility to a few meters. This situation made it impossible for the submarine to anticipate any danger. It exponentially increased the risk of collision. One of the most vital lifelines for submarines in World War I was undoubtedly their fuel. However, these fuel systems were completely inadequate for long-term operations in a remote and isolated region like the North Pole. Submarines of that era typically used heavy fuel oil or diesel. This fuel powered the diesel engines while surfaced, and also charged the batteries for the electric motors. But let's see together how fragile this system was under polar conditions. First, the fuel itself was a problem. Heavy fuel oil is a fuel with low viscosity, meaning fluidity decreases as temperature drops. The colder the air, the more the fuel thickened, becoming almost like molasses. In the freezing cold of the North Pole, the fuel oil in the ship's tanks could not be pumped to the engines fast enough. Clogs could occur in pipelines. This situation could hinder the efficient operation of diesel engines, even cause them to fail completely. Imagine the engine starting to sputter while trying to navigate among ice. It was a complete nightmare. Storing fuel near its freezing point also placed an excessive burden on pumping systems and filters. The second and perhaps most critical problem was the range of the submarines. 1914 model submarines did not have the capacity to cover thousands of kilometers like today's nuclear submarines. Although diesel engines provided a good range, this was only available while traveling on the surface. The situation changed completely when they submerged. Due to the limited lifespan of the batteries, submarines could only stay underwater for short distances. A few hours of underwater travel was enough to deplete the batteries. This forced the vessel to surface at frequent intervals to recharge the batteries with the diesel engines. Surfacing in an ice-covered region like the North Pole was a suicide mission in itself. The submarine could become trapped under the ice sheet. It might not find a safe spot to surface, or it could get stuck among rapidly forming ice, completely losing its maneuvering ability. Moreover, surfacing increased the risk of detection by enemy ships or reconnaissance aircraft. In wartime, such a risk could lead to the submarine's destruction. Refueling was a complete enigma. Considering the desolate and inaccessible nature of the North Pole, finding a refueling base or support ship for the machine was nearly impossible. A rendezvous with a fuel tanker amidst ice in the middle of the ocean was no different from science fiction. Therefore, a unit was limited to the fuel it carried on its mission, and this posed an insurmountable obstacle to any prolonged patrol or operation. When fuel ran out, the submarine turned into a massive metal coffin drifting at sea. The crew's chance of survival approached zero. The submarine was essentially a metal capsule underwater, a living space completely isolated from the outside world. One of the most basic necessities for the survival of the crew in this enclosed environment was breathable air, i.e., oxygen, and the maintenance of this air's quality. In the submarines of the World War I era, in stark contrast to the advanced life support systems of the modern age, these vital needs were addressed in an extremely primitive manner. In a harsh environment like the North Pole, The inadequacy of these primitive systems was one of the most critical factors that could spell the end. While submerged, it was impossible to replenish the submarine with fresh air. The crew had to make do with the limited amount of oxygen they brought with them. The oxygen tanks of that era typically stored oxygen under high pressure. These tanks were opened at certain intervals when the oxygen level in the internal air dropped to critical levels. However, this was a manual process, and constantly monitoring oxygen levels and intervening at the right time without error was quite difficult, especially in stressful or emergency situations. If a tank ran out or malfunctioned, even if there were backups, the depletion of this limited life-giving gas was a problem. Running out of oxygen meant the crew would die. Just obtaining oxygen wasn't enough. In the closed working order, due to respiration and other sources on board, such as the exhaust from diesel engines, oil vapors, carbon dioxide (CO2), would constantly accumulate. High concentrations of CO2 have a toxic effect. It causes headaches, nausea, dizziness, and can eventually lead to loss of consciousness and death. Therefore, the air needed to be continuously filtered and contaminants removed. In 1914 model submarines, this was usually done with systems called CO2 scrubbers or cleaners, made of limestone, calcium hydroxide. These systems cleaned the air by absorbing CO2 through chemical reactions. However, these scrubbers also had limited capacities and would be exhausted after a certain period of use. Backups were mandatory, and the weight and volume of backups were a serious issue. Also, for these systems to work effectively, a certain humidity and temperature balance was required, which in the freezing environment of the North Pole was a struggle in itself. Cold could slow down chemical reactions or cause them to malfunction. The gas threatening the interior of the submarine crew was not just carbon dioxide. During battery charging, hydrogen gas could be released. Hydrogen is an explosive gas at high concentrations. In other words, one could unknowingly be carrying a bomb inside the submarine. Furthermore, sweat, odors, and other biological waste emitted by the human body increased the general staleness, humidity, and distribution of the air, and in long-term confinement situations, it created a breeding ground for respiratory illnesses. Inadequate ventilation and unfiltered air increased the spread and multiplication of pathogens. Considering the necessity for a submarine in the North Pole to stay submerged for long periods, unable to surface due to ice or impossibility, these oxygen and air filtration problems took on a more critical dimension. When the batteries were being charged, the electric motor stopped. This meant the fans providing air circulation would also stop. A dark, airless, and isolated environment would leave the crew in helpless despair. Under these conditions, the capacity of the oxygen tanks and CO2 scrubbers was the most important factor directly limiting how long the unit could stay submerged. Air would run out, CO2 levels would rise, and the crew would be unable to breathe. This was as dreadful an end as freezing or collision. One of the fundamental pillars of survival at sea is not just breathing but also having potable water. Compared to today's waters with advanced desalination systems that convert salt water to fresh, in World War I era technology, this was extremely primitive, almost non-existent. In a remote region like the North Pole, the lack of access to fresh water sources posed a significant threat due to these deficiencies. Submarines of that era typically carried limited amounts of fresh water in tanks, loaded according to the mission and its duration. This water was used for both drinking and basic hygiene. However, the capacity of these tanks was absolutely insufficient for a polar mission lasting weeks or even months. Each member of the crew had to minimize daily water consumption to a minimum. Thirst would quickly reduce performance, cause fatigue, and lead to tension among the crew. Excessive water restriction could lead to serious health problems, dehydration, kidney issues, and ultimately death. So, what options were available for making seawater drinkable? Theoretically, desalination through distillation was possible. That is, boiling seawater and condensing the steam to obtain fresh water. However, this process presented major challenges in a closed, energy-limited environment like a submarine. First, boiling required a significant amount of fuel. Considering the submarine's already limited refueling capacity, using this method continuously was impossible. Fuel was barely enough for the submarine to move. They couldn't spare an extra gram of ballast for boiling water. Secondly, the distillation process produced a large amount of heat and moisture. In the submarine's already stuffy and humid environment, this created unbearable conditions for the crew, making the internal air even more suffocating. Excessive moisture caused malfunctions in electronic components and other equipment, increasing the risk of short circuits. Thirdly, operating and maintaining such a system with the simple science of that era was quite difficult. Complex pipe systems, filters, and condensers were sensitive parts prone to failure. Utilizing melted ice in the North Pole might seem like an option. However, this was also impractical. The submarine needed to collect ice from the surface and then melt it. This process increased the risk of detection by external elements among the ice, and the melting process again required extra energy. Additionally, water obtained from melting sea ice was not guaranteed to be completely fresh. During ice formation, some salt could be trapped. While theoretically possible to collect melted snow or surface ice water, it was practically impossible in terms of the unit's stealth and operational security. Therefore, in World War I submarines, meeting the drinking water needs of the crew in a region completely isolated from the outside world and with zero water resources like the North Pole was an insurmountable problem. Thirst is a factor leading to death faster than hunger, and even in the event of a submarine sinking, it was uncertain how long the crew could endure this difficult operation without water. The lack of access to potable water would disrupt the crew's physical stamina, break their morale, and make their survival struggle even more desperate. This situation, combined with the fundamental constraints, made long-term operations in the North Pole impossible. In the cold, dark, and humid depths of submarines, nutrition is as essential for survival as oxygen and water. However, in World War I-era submarines, food security and storage conditions were nothing short of an invitation to disaster for long-term, isolated use like in the North Pole. In an era without modern refrigerators and freezers, keeping provisions fresh required a miracle in itself. Submarines of that era were typically stocked with low spoilage foods like canned goods, salted meat and fish, dried fruits, biscuits, and crackers. Although fresh vegetables and fruits are sources of vitamins, they were hardly ever carried due to limited storage space and rapid spoilage. Those that were carried could only stay fresh for a few days. This situation would lead to nutritional deficiencies and scurvy, vitamin C deficiency, for the team. Especially among sailors, vitamin C deficiency was a widespread problem leading to scurvy. Scurvy, which causes symptoms such as gum bleeding, joint pain, difficulty in wound healing, and general weakness, could lead to death when it progressed. On a long-term polar mission, in the absence of medical assistance, the crew's ability to cope with such a condition was limited. The storage conditions for food were a nightmare in themselves. Inside the submarine, despite the cold of the North Pole, humid and variable temperatures could occur due to engine and equipment heat. This environment created ideal conditions for the proliferation of microorganisms and food spoilage. Even canned goods could leak, or their contents spoil if exposed to extreme temperature changes or shocks. Salted meat and fish could become moldy or infested with worms if not stored properly. Rats and other pests could also pose a problem inside the ship, damaging supplies. Storage space was a serious limitation. In the already cramped and confined interior of the submarine, where finding space even for the crew was difficult, storing enough food for weeks or months was physically challenging. Food was stacked near the crew's bunks, in narrow corridors, or near machinery spaces. This situation led to hygiene issues and also hindered the preservation of food. Damage, dampness, or mixing of food packages was also common. The psychological effects were undeniable. Constantly eating the same monotonous food seriously lowered the crew's morale. Being deprived of fresh food, monotony, and isolation had a devastating impact on the mental resilience and morale of the crew. Hunger and poor nutrition were triggers for irritability, hopelessness, and irrational decisions. This could fuel intra-crew friction and disrupt discipline in the already harsh polar conditions. In a scenario where resupply from the outside world in the North Pole was nearly impossible, food replenishment was more than a fantasy. Even for a support ship to reach the submarine amidst the glaciers or for the submarine to reach a safe port was extremely difficult. Therefore, once a submarine entered the North Pole, it had to make do with the provisions it had. This system of limitations, rapidly deteriorating supplies, and major obstacles made long-term survival of the crew impossible. When the submarine's steel hull plunged into the freezing waters of the North Pole, protecting the crew inside from the brutal cold outside was of vital importance. However, the heating systems in submarines during the World War I period were no match for the difficulty of this task. This situation left the crew constantly at risk of hypothermia, turning the interior into a floating ice block. Submarines of that era did not have complex structures similar to the central heating systems of modern ships. The interior temperature was maintained only with waste heat from the engine exhaust and a limited number of steam or electric heaters. But these fluctuations were completely inadequate against polar temperatures, which hovered below zero. The freezing cold of the steel components of the submarine was easily transferred inside. Walls and floors would be ice cold. The bunks where the crew slept, their clothes, and blankets were insufficient to protect them from the cold. Constant, drastic temperature fluctuations over long periods had a devastating effect on the human body. Hypothermia, that is, a dangerous drop in body temperature, was a major threat. Shivering, lethargy, loss of coordination, confusion, and eventually loss of consciousness and death were the stages of hypothermia. Living constantly in the cramped and confined environment of the submarine, forced to wear damp and wet clothes, further increased the risk of hypothermia. Many of the crew lived with a constant feeling of cold. This distracted them and made it difficult for them to perform their duties. Serious health problems like frostbite in fingers and toes, nerve damage, and gangrene also became inevitable. The cold didn't just affect the people, it affected the submarine itself. Mechanical systems and sensitive instruments performed poorly in extreme cold. Lubricating oils would freeze, metal parts would contract, and clearances would change. This could lead to failures in engines, pumps, valves, and hydraulic systems. Especially, battery performance was severely affected by the cold. Low temperatures reduced the battery's ability to store and deliver power. This further shortened the submarine's submerged endurance. Valves for ballast tanks used to expel seawater or parts of torpedo tubes could freeze. This situation could cause loss of control or serious security breaches for the submarine. Considering the impossibility of heating fuel in the North Pole, spending extra fuel for heating would also be a luxury. The already limited fuel was barely enough for the submarine to move. This meant the crew had to forego the comfort of heating. The lack or failure of heaters would further lower the interior temperature. It would cause condensation of moisture and the formation of ice layers on metal surfaces. This icing would make life inside the vessel even more unbearable. In conclusion, the primitive heating systems of World War I submarines would completely fail to protect the crew from the freezing cold of the North Pole. Hypothermia, frostbite, and equipment failures were significant factors that threatened the physical and mental faculties of the crew, reduced the submarine's operational capabilities to zero, and ultimately destroyed their chances of survival. Under these conditions, the crew had to fight not only external enemies but also the insidious, chilling cold inside their own ship. For a submarine navigating the vast, ice-covered waters of the North Pole, finding its way was akin to a blind man trying to navigate a labyrinth. The navigation and mapping technologies of the World War I era were completely inadequate under the extraordinary and relentless conditions of this geography. The conveniences available to you today, such as GPS satellites, digital maps, or advanced sonar systems, were merely science fiction at the time. This technological blindness largely sealed the submarine's fate. First, magnetic compasses did not work reliably in the North Pole. As one approached the magnetic North Pole, the compass needle deviated from true north and eventually began to spin meaninglessly. This phenomenon is called magnetic deviation and was so severe in polar regions that the basic direction-finding tool of a ship became useless. When a ship's fundamental navigation tool became useless, determining direction became impossible. In addition to the compass, gyro compasses used at the time were not yet fully reliable and were not advanced enough to completely replace the magnetic compass. This condemned the submarine to proceeding blindly. The second major problem was the lack of mapping. The North Pole was a largely unexplored and unmapped region in 1914. Submarines did not have detailed bathymetric, seafloor depth, charts or current maps showing ice formations. The existing maps were based on rough measurements from surface ships and could be very unreliable. Imagine moving underwater with the risk of colliding with an iceberg or a seamount. But you have no guide showing you where hazards are or what lies ahead. Collisions were almost inevitable. Visual navigation was also impossible. A submarine on a mission often had to remain submerged for long periods, and underwater visibility often did not exceed a few meters. Periscopes could only be used when near the surface. However, the often foggy, snowy, or ice-covered surface of the North Pole prevented even periscopes from making healthy observations. Observing the surface course was often impossible both due to the risk of detection and because of massive ice masses. The lack of visual references also made navigation even more complex. The constantly changing ice cover and currents in the North Pole made navigation even more difficult. Ice masses constantly shifted with winds and ocean currents, rendering the route the submarine had planned obsolete. A seemingly clear path one moment could turn into a massive ice barrier a few hours later. Predicting this dynamic environment accurately was impossible. The submarine could become trapped in this moving ice labyrinth, drifting into unknown and dangerous waters. In conclusion, finding an accurate path in the North Pole was an insurmountable task for World War I submarines. The uselessness of magnetic compasses, the the lack of mapping, the impossibility of visual navigation, and the constantly changing ice conditions left them at the mercy of fate. A navigation error could lead to the submarine being crushed under ice, colliding with an iceberg, or getting lost. This situation was an additional source of hopelessness for the crew already struggling with cold, lack of air, and thirst, and was one of the biggest factors making the submarine's survival in the North Pole impossible. World War I submarines were fundamentally designed to operate in shallow coastal waters and open seas. The purpose of their existence was to stealthily approach and strike enemy ships with torpedoes. However, the underwater world beneath the Arctic ice was completely contrary to this design and left the submarines of that era desperately inadequate in this extreme environment. But it wasn't just a technical deficiency. It was an existential part of the vessel. Today's modern nuclear submarines can remain under ice, avoid icebergs thanks to special sonar systems and reinforced hulls. They can even have special equipment for surfacing through ice. In contrast, 1914 model submarines were so fragile in structure that they could not maneuver under ice and would suffer serious damage even from the slightest contact with ice. The submarine's outer hull was not built to withstand extreme pressure. The pressure hull, which bore the main load, was protected by a thin outer casing. This thin casing could tear upon impact with a piece of ice, leading to water leaks and dangerous weaknesses in pressure integrity. One of the most important elements making it impossible for a submarine to move under ice was its limited maneuverability. An iceberg is not just a piece visible on the surface. A large part of it is hidden underwater, and there can be ice ridges or underwater ice sills extending for kilometers. For a submarine to navigate under these massive and invisible ice masses, it would need to constantly change depth, i.e., dive and rise. However, the ballast tank systems of that era were not as fast and precise as modern submarines. Filling or emptying ballast tanks was a time-consuming and imprecise process. When sudden obstacles were encountered under ice, it was very difficult for the submarine to change depth quickly. While trying to avoid an obstacle, hitting an ice mass due to lack of control or insufficient maneuverability could cause the vessel to become stuck, or its structure to be crushed. Furthermore, periscope use was useless in under-ice operations. The submarine's eye, the periscope, could not be used to observe the surface covered by ice. While under ice, the submarine was literally blind. Sonar systems at the time either did not exist or were so primitive that they could not be used to reliably detect ice masses and measure their distances accurately. This meant the submarine was proceeding into the unknown with the risk of colliding with an obstacle. Another challenge regarding mobility in ice was the submarine's noise level. Diesel-electric systems were not as quiet as modern submarines. Even while moving underwater, a certain level of noise was emitted from the engines, pumps, and other systems. This noise increased the risk of acoustic detection. Although there might not be anyone to detect them in the North Pole, it also made it difficult for the crew's own sonar to function. Signals from navigation and sonar could be distorted, echoing off the ice. A submarine mission always carried certain risks. However, in a merciless and isolated environment like the North Pole, during World War I, an emergency for a submarine meant near total helplessness and zero chance of rescue. The advanced escape capsules, emergency signal flares, or satellite-assisted distress call systems found in modern submarines were dreams of the space age for 1914 technology. Once a submarine became trapped in the ice or suffered a breakdown, the crew was largely left to their fate. Even the simplest emergency scenario, such as the submarine's batteries running out or a motor failure, turned into a massive crisis in the North Pole. In open seas, surfacing and waiting for help might be possible, but in the North Pole, if there was an ice sheet meters thick on the surface, the crew would remain trapped inside like a coffin. Breaking through the ice layer to surface was impossible with the submarine technology of that era. The hull was not designed to withstand the pressure of ice, and such an attempt would have led to the hull being crushed. Rescue operations were completely a fantasy. The North Pole was a region that was only occasionally traversed by expeditions at that time, largely unmapped and inaccessible. There were no ships regularly navigating the area or a rescue infrastructure. The infrastructure for a submarine to send a distress signal was insufficient. Wireless telegraphy and radio were not advanced enough for submarines to use effectively while submerged. Even if they could surface and send a radio signal, it was a great mystery how far this signal would travel and whether anyone was listening. Moreover, even if a signal was received, it could take weeks or even months for a rescue ship to reach that area. If it could reach at all. Sea ice would hinder the progress of rescue ships, also endangering them. The crew's chance of abandoning the submarine was almost non-existent. Submarines of that era did not have modern escape capsules or individual rescue equipment. If the submarine began to sink or flood, trying to escape through the hatches in freezing cold and under pressure would instantly lead to hypothermia. Even if they jumped into the water, surviving more than a few minutes in the icy water was impossible. Life rafts or lifeboats they might carry would be of no use. In the worst-case scenario, the submarine would be damaged under the ice and begin to flood. In that case, the only thing to do was try to slow the flooding and accept their fate. Without rescue teams or support ships, there was no hope for a submarine crew cruelly stranded in this way. Any mechanical failure, a collision with an ice mass, or a breakdown would trap the crew in the submarine's metal coffin, leaving them to die completely disconnected from the outside world. This situation, along with other dramatic and hopeless factors, made survival in the North Pole impossible for the crew. The struggle for survival on a World War I submarine in the North Pole was not limited to mechanical failures or attack dangers. The real battle was fought within the crew's own inner world. The psychological impact of being in a closed, dark, cold, and isolated environment for a long time deeply shook the crew's morale and mental faculties. It reduced their efficiency to zero, seriously diminishing their chances of survival. Imagine the cramped and confined interior of a submarine. A World War I submarine of that size housed about 30 to 40 people. These people had to live for weeks, even months, inside a tube consisting only of narrow corridors and tiny compartments. There was no privacy. Personal space was at a minimum. They constantly felt each other's breath on their necks. As this situation continued, it wore down nerves, reduced tolerance, and caused even the smallest issues to turn into major arguments. Tensions, fights, and discipline problems among the personnel were inevitable. One of the greatest challenges was sensory deprivation. There was almost no visual or auditory contact with the outside world. Not seeing sunlight led to long-term vitamin D deficiency. This was also a trigger for depression. Inside the submarine, there was only monotonous, dim, artificial lighting. There were no natural sounds like the wind or the lapping of waves. Only the hum of machinery, the sound of pumps, and the whispers of the crew were present. This constant, unchanging environment could lead to mental fatigue, hallucinations, and detachment from reality. When the human mind is deprived of natural stimuli, it can create its own dark corners. The uncertainty of the future deeply affected morale. A submarine in the North Pole was at constant risk of colliding with an iceberg, experiencing engine failure, or running out of fuel. Knowing that rescue was nearly impossible in this region, the crew lived with a constant fear of death. This constant stress and anxiety disrupted sleep patterns, caused loss of appetite, and created a general state of exhaustion. Insomnia impaired judgment. It increased the likelihood of errors, and in a delicately balanced mechanism like a submarine, such errors were catastrophic. The deterioration of hygiene conditions was another factor leading to low morale. Limited fresh water and shower options prevented regular cleaning. Constant sweat, dirt, and body odors made the already cramped environment even more unbearable. This situation increased both physical health risks and lowered the crew's self-respect and general motivation. In conclusion, the crew of a World War I submarine in the North Pole had to fight not only external enemies but also the psychological pressures arising from their own minds and the closed environment. Sensory deprivation, performance anxiety, lack of privacy, and hygiene problems demoralized the crew, triggered panic attacks and psychological breakdowns. This situation reduced the submarine's operational capability to zero. It increased mistrust among the crew and completely eliminated their chance of survival. For a ship's crew is only as strong as its mental health, and the North Pole was the most ruthless testing ground for this strength. World War I submarines essentially consisted of a series of complex mechanical systems. Engines, pumps, valves, hydraulic components, and electrical systems. Each was designed to perform optimally under specific conditions. However, the brutal and freezing cold of the North Pole would push these systems beyond their endurance limits, condemning them to failures and even complete inoperability. Every screw, every gasket of the submarine was a weak link of this magnitude. The most critical systems, the engines, both diesel and electric, were directly vulnerable to extreme cold. Diesel engines required a specific temperature to operate. The freezing or increased viscosity of the fuel oil in the lines would prevent fuel from reaching the engines. Lubricating oils in the cylinders would also thicken, making their distribution difficult and hampering the engine's operation. This could lead to overheating and, ultimately, the engine seizing up. The batteries for the electric motors would rapidly lose their capacity at low speeds. Just as a phone battery dies faster in winter cold, the submarine's massive batteries also saw their power output weaken in the polar cold, dramatically shortening the submarine's submerged endurance. Hydraulic and mechanical systems were at great risk. Vital systems like the ballast tank valves that controlled the submarine's depth, the hydraulic mechanisms that raised and lowered the periscope, or the torpedo tubes, operated with fluid or air pressure. The fluids, oils, and moisture in the air used in these systems could freeze and solidify or cause icing in the pipes in freezing cold. A frozen valve could prevent a ballast tank from functioning correctly, leading to loss of control over the submarine's diving or surfacing. A jammed torpedo tube door would not only nullify attack capability, but also create a safety risk. Pumping systems faced similar difficulties. Water pumps were vital for draining water accumulating inside the submarine or taking water into the ballast tanks. Freezing could crack the pump's internal parts, shatter their impellers, or burst their pipes. This would lead to water leaks and potentially cause the submarine to take on water inside its machinery spaces, a dangerous situation, especially for electrical systems. The durability properties of electrical cables could also be affected by the cold, becoming brittle and snapping, leading to short circuits. All externally visible mechanisms of the submarine, from periscope lenses to ventilation hatches, sensors, sonar, if any, even primitive ones, and transducers, were in danger of icing. Ice layers forming on these external systems could completely disable them. If the periscope's external lens became coated with ice, seeing outside would become impossible. If air intake and exhaust vents froze, internal airflow would quickly deteriorate. The North Pole was not just a static ice sheet. The waters beneath it are constantly in motion, and these movements also drag the surface ice masses. For World War I-era submarines, these ocean currents and moving glaciers made navigation even more complex, increased the risk of collisions, and created unpredictable dangers of entrapment and crushing. A 1914 submarine, without modern, oceanographically organized, and advanced sonar systems, was navigating blindly and defensively in this dynamic and dangerous underwater maze. Firstly, powerful ocean currents were a problem in themselves. In the North Pole, particularly around Greenland and the Canadian archipelago, deep ocean currents exist. These currents could drag a submarine traveling underwater in unexpected directions, altering its plotted course. Correcting the submarine's course and direction without knowing the strength and direction of the current was nearly impossible. Progressing against the current led to greater fuel consumption, further shortening the already limited range. Drifting with the current meant the submarine could lose control completely and be swept into unknown, dangerous areas, shallow reefs or underwater ice ridges. This loss of control created immense psychological pressure on the crew because it heightened the feeling of helplessness, knowing their ship was moving not only by their will but also by natural forces. Secondly, and perhaps an even greater threat, was the mobility of the ice. The ice cover in the polar region constantly shifts and changes place due to winds and ocean currents. Sometimes immense icebergs, sometimes ice floes stretching for kilometers, would move insidiously. World War I submarines either had no sonar systems or had systems inadequate for detecting underwater ice masses. This meant that while moving underwater, a submarine could unexpectedly encounter a moving ice wall. Such a collision would cause serious damage to the submarine's hull, lead to water leakage, and potentially cause it to sink. Moreover, these moving ice formations could also block the submarine's escape route. A thick ice sheet appearing above a submarine trying to surface could trap it in the depths. The pressure of the ice could crush the submarine's outer hull, lock the escape hatches, and leave the crew to die from suffocation or flooding. Open water leads to the surface could close up or refreeze very quickly. This created a vicious cycle, rapidly depleting the already limited oxygen supply. These invisible dangers created constant tension and stress on the submarine crew. The risk of collision or entrapment made an environment that was already harsh and hostile even more unbearable. No matter how skilled and disciplined the crew was, there was nothing they could do to counter these massive and unpredictable forces of nature. Ocean currents and moving glaciers were fundamental and merciless realities that made survival in the North Pole impossible for World War I submarines. The submarine's fate was sealed in this dynamic labyrinth of ice and water. For a submarine, navigation is the most basic condition for survival at sea. However, the navigation technology of the World War I era was completely helpless against the unique magnetic field of the North Pole. Without precise tools like modern gyroscopic compasses or global positioning systems, GPS, a 1914 model submarine's direction finding in the polar region was akin to a blind man lost in a labyrinth. This situation cast the submarine into uncertainty and kept the crew in a state of constant anxiety. The biggest problem was the failure of their primary navigation tool, the magnetic compass. As one approaches Earth's magnetic poles, the compass needle deviates severely towards magnetic north instead of showing true north. In the North Pole, this deviation is so great that the compass begins to spin erratically or refuses to give a stable reading. This phenomenon, known as magnetic deviation or declination, was impossible to accurately compensate for with the understanding of 1914. When the submarine was deprived of its basic direction indicator, proceeding on a correct course and reaching an intended target became impossible. This created a constant sense of being lost and hopelessness for the crew. Aside from the magnetic compass, the gyro compasses used at that time were also not ideal for polar regions. Gyro compasses operate based on Earth's rotation to indicate true north. However, in polar regions, due to proximity to the axis of Earth's rotation and changes in gravitational forces, gyro compasses could make erratic and erroneous readings. Furthermore, gyro compasses were large, heavy, and complex systems. They required frequent calibration and were prone to failure. Ensuring such a sensitive device worked correctly in the submarine's cramped and humid environment was quite difficult. Having a backup gyro compass was not always possible, and even if available, it was no guarantee of correct results. Astronomical observations used for navigation of the sun stars were generally inapplicable in the North Pole. For a large part of the year, especially in winter, the North Pole is in continuous darkness or twilight, making sky observation impossible. Observations made even with a periscope were often futile due to fog, snowstorms, and dense ice cover. The effort to surface for observation also increased the submarine's risk of detection and the danger of becoming trapped among the ice. World War I submarines, in the remotest regions of the world like the North Pole, had to contend not only with natural dangers but also with the severance of connections with the outside world. Communication technology was not advanced in 1914, and this situation condemned the submarine crew to a completely isolated existence. Calling for help, getting information, or being aware of any developments was a fantasy. Communication for submarines of that era primarily relied on wireless telegraphy, i.e., radio. However, these radio systems did not work underwater. Radio waves could travel only very short distances through water and could not be transmitted efficiently. This meant the vessel had to surface for communication, a must. As we mentioned in earlier analyses, surfacing in the North Pole was a suicidal act in itself. A thick ice sheet could physically prevent surfacing, or the submarine could get crushed among the ice while attempting it. Additionally, a surface submarine risked detection by potential enemy ships or reconnaissance aircraft. This risk was unacceptably high in wartime. Even if they did surface, the range of the transmitted radio signal was quite limited. Shortwave radio technology was still in its infancy, and reliable communication over long distances was difficult. The nearest communication station in a desolate region like the North Pole could be thousands of kilometers away. This meant that a sent distress call, a malfunction report, or a positional report might never reach a recipient. It also depended on chance factors like a permanent station being continuously open and tuned to the correct frequency. Additionally, geomagnetic storms like the aurora, northern lights, and polar regions could seriously interfere with radio communication, causing signal distortion or complete disruption. These natural events rendered the already weak communication systems even more dysfunctional. The crew's disconnection from the outside world was not just a technical matter. It also had a deep psychological effect. Not hearing from families, friends, or the progress of the war deeply shook the crew's morale and motivation. This feeling of helplessness fueled loneliness, hopelessness, and desperation. Not knowing what was happening outside increased the crew's stress levels and eroded their resilience. The non-arrival of an expected rescue operation or a message going unanswered would push the crew deeper into despair. One of the most basic needs for a submarine's survival is its ability to withstand immense pressure when submerged. However, the hull structures and construction methods of World War I-era submarines were completely inadequate against the extreme depths and, especially, the external pressure that an ice sheet could apply in the North Pole. This inadequacy rendered the vessel as fragile as a thin eggshell, ready to be crushed at any moment. Submarines of that era were generally made of high-tensile steel. But the welding techniques and conditions of the time were quite primitive compared to modern submarines. Their designs were optimized for operations in open seas at shallow depths not exceeding a few hundred meters. The engineering knowledge and material technology to withstand tons of pressure per square millimeter in the deeper layers of the ocean did not yet exist. In the North Pole, the submarine had to contend not only with water pressure but also with the additional pressure from being under glaciers and ice masses or being crushed by them. Becoming trapped under an ice sheet would apply incredible pressure to the submarine's hull from the sides and above. This pressure would rapidly compromise the vessel's structural integrity, causing steel plates to buckle, rivets to pop, or welds to fail. Every penetration point on the submarine's hull, pipe entries, hatches, valve passages, etc., was a potential weak point. Under pressure, the risk of water leakage from these points was very high. The smallest crack created by the ice's pressure could rapidly expand, causing large amounts of water to flood into the submarine. Incoming water would lead to short circuits in electrical systems, disable battery units, and upset the vessel's balance and buoyancy. The submarine would begin to sink uncontrollably deeper and eventually be crushed by the pressure upon it. Furthermore, the submarine's hull design had no capability for under-ice maneuvering or ice braking. The hull was fitted with sensitive propellers, rudders, and external sensors that could easily be damaged upon impact with ice. Modern submarines have reinforced sails or special ice-breaking capabilities for surfacing through ice. These were absent in 1914 submarines. The bow shape of World War I submarines was designed for easier penetration into water, not for breaking ice. This would cause the front section to deform easily upon contact with ice. If the submarine remained in the ice for long periods, a serious problem of ice accretion on the outer surface could occur. This accumulated ice would both increase the submarine's weight and negatively affect its hydrodynamics. Additionally, the icing over of periscopes, sensors, and other exposed devices would completely nullify their capabilities. Serving on a submarine in World War I already carried inherent health risks. However, in a merciless and isolated environment like the North Pole, where the possibility of medical assistance was almost zero, the crew was left completely helpless against even the simplest health problems or injuries. Inside the submarine, far from an operating room, was a cramped and unhygienic living space where infections could easily spread. Submarines of that era typically did not have a full-time doctor. On these vessels operating with a small crew, a petty officer with some medical training or a simple first aid kit would suffice. These kits contained only basic bandages, antiseptics, pain relievers, and perhaps a few simple medicines. In the case of a serious injury, for example, a burn from a machinery malfunction, a broken limb, or internal bleeding, effective treatment with these limited resources was impossible. At best, they could try to alleviate pain and prevent the condition from worsening. The submarine's closed, humid, and stuffy environment provided ideal ground for the proliferation of pathogens. An illness like a cold or flu affecting one crew member could quickly spread throughout the entire ship. Common areas, insufficient ventilation, and lack of hygiene allowed bacteria and viruses to easily propagate. An epidemic could incapacitate a large portion of the crew, completely changing the submarine's operational capability. Being stranded for a long time on a submarine in the North Pole meant not only battling ice and cold. It also meant the crew's physical and mental systems being deeply affected by a complete deprivation of sunlight. Particularly in this region, governed by the polar night regime for a large part of the year, the lack of natural light sources led to vitamin D deficiency and a host of associated health problems, seriously reducing their chances of survival. A large portion of the human body's vitamin D is synthesized in the skin when exposed to sunlight. Vitamin D is vital for bone health, the immune system, and general mood. Although the artificial lighting inside the submarine provided some light, this light did not have the spectrum of natural sunlight, and vitamin D synthesis was completely inadequate. After a mission lasting weeks or even months, severe vitamin D deficiency would appear in almost the entire crew. The physical effects of vitamin D deficiency were devastating. One of the most evident problems was the deterioration of bone health. In adults, it commonly led to conditions like osteomalacia and osteoporosis. Scurvy would have profoundly affected the crew's physical and mental faculties, making it impossible for them to perform their duties. Inadequate nutrition further aggravated this situation, making them more susceptible to other diseases. Digestive problems and other chronic ailments were also frequently seen. Accidents were inevitable. In the submarine's cramped, machinery-filled environment, injuries from falls, collisions, or crushing were highly likely. Fire risk was always present. In a fire, the smoke and chemicals released would cause serious damage to the already vulnerable systems. In such emergencies, the lack of basic health facilities could lead to casualties. Vitamin D is also critical for the immune system. Deficiency reduced the crew's resistance to infections. If one person fell ill in the already closed, stuffy, and crowded submarine environment, it could quickly turn into an outbreak. Crew members with weakened immune systems would have to struggle much more severely even with simple illnesses like a cold, and recovery periods would be prolonged. This further sapped the submarine's operational strength. In addition to the physical effects, the psychological impact could not be ignored. The lack of sunlight directly affected the crew's mood. Sunlight plays an important role in the secretion of neurotransmitters like serotonin, which regulate mood. Deprivation of natural light could lead to chronic fatigue, irritability, and even clinical depression. Increased hopelessness, lack of motivation, and heightened anxiety levels would be observed among the crew. This could disrupt the harmony and cooperation of a submarine crew already under high stress. Not knowing what time of day it was also disrupted biological rhythms, circadian rhythms, and undermined sleep patterns. Long-term lack of sunlight could have negative effects on the eyes. It could particularly reduce night vision capability. Working inside the submarine with insufficient light and constantly looking at the same distance would cause eye strain and headaches. In the North Pole, there was no chance of getting vitamin D from outside. The medical knowledge and equipment of that period were insufficient to diagnose and remedy such a deficiency. During this process, the crew had to struggle alone with these insidious and progressive health problems. The lack of sunlight and vitamin D deficiency emerged as a significant factor that profoundly affected the crew's overall performance, morale, and intervals, making their survival in the North Pole just as impossible as any technical or mechanical weakness. Contrary to belief, the cold and desolate expanses of the North Pole were not completely empty. This merciless geography hosted its own wildlife, and for a World War I submarine, these creatures, especially polar bears, could sometimes be as unexpected and collapsing a danger as icebergs. The struggle for survival outside sometimes meant encountering a predator you never expected. Polar bears were the undisputed largest and most dangerous predators of the North Pole. Their sense of smell was extremely developed, and they could pick up the scent of their prey from kilometers away. In scenarios where a submarine surfaced through the ice, opened ventilation hatches, or had crew members checking something outside, the submarine could be perceived by polar bears as a potential food source. The bear's powerful paws and jaws could leave serious marks even on a metal surface, and could even damage the submarine's thin external hull casing. Encountering a bear on the submarine's deck or on the ice meant direct death for an unarmed or inadequately armed crew member. In case of a bear attack, there was no escape in the confined space, and such an encounter would cause panic among the crew. It wasn't just polar bears. Other marine creatures could also pose potential dangers. Large whale species or walruses could unknowingly collide with the submarine, causing hull damage. Although this risk was much lower than the risk of colliding with an iceberg, it was still a non-negligible possibility. Walruses, in particular, with their sharp tusks, could inflict damage even on ice. If a submarine remained motionless on the surface, these creatures might approach the ship out of curiosity and cause damage before moving away. The risk of wildlife encounters made the submarine's surfacing operations even more perilous. When the crew had to surface to recharge batteries or refresh the air, they had to consider not only enemy ships or glaciers but also the wild animals roaming on the ice. This surfacing would turn into not just a technical maneuver but also a survival test with the potential for a confrontation with an unexpected predator. Even if there was no direct harm from wildlife inside the submarine, the indirect moral and psychological effects on the crew could be seen. The unknown threats outside, the constant state of alertness, and the feeling that a danger might be lurking at the door increased stress. Especially in a situation where food supplies were limited, the presence of game animals outside could deepen the crew's sense of hopelessness. Now we have come to the end of this freezing and arduous journey. We have examined one by one why World War I-era submarines could not survive the relentless conditions of the North Pole. This story is not just a list of technological limitations, but also the story of a desperate struggle of mankind with the most primitive tools against nature's toughest forces, a struggle destined to fail. In summary, accomplishing such a mission was impossible. Firstly, the inadequacy of the design was a fundamental obstacle. 1914 model submarines were not designed to maneuver under ice, stay submerged for long periods, or endure extreme cold. Their limited battery life, primitive fuel systems, and restricted range made them candidates to run out of fuel under an iceberg or in the open sea in the North Pole. The freezing of mechanical parts, solidification of oils, and failure of sensitive devices would turn the ship into a dysfunctional pile of metal in seconds. Secondly, the North Pole's own merciless nature was insurmountable with the technology of that era. Constantly moving, unpredictable ice masses were a constant threat to the submarine's existence. Invisible icebergs could easily shatter or trap the ship. The freezing cold affected not only the crew but every part of the ship, leading to system failures. The continuous darkness for a large part of the year made navigation impossible and deeply shook the crew's psychology. Thirdly, the primitive nature of life support systems would lead to their physical and mental collapse. Limited oxygen, inadequate air purification systems, lack of potable water, and deteriorating food storage would quickly leave them facing thirst, hunger, and respiratory problems. Lack of sunlight and vitamin D deficiency would lead to serious health problems like long-term depression and bone issues. The absence of medical aid and backup meant even the simplest illness could turn into a catastrophe. Finally, isolation and lack of communication reduced the chance of rescue in any emergency to zero. Once a submarine descended into the icy waters of the North Pole, its connection with the outside world was completely severed. Distress calls went unheard. Rescue teams could not reach the area. This situation made the crew feel completely abandoned to their fate, increasing hopelessness and panic. While any one of these reasons alone could spell the end for a submarine crew, when all came together, surviving in the North Pole with a submarine during World War I was nothing more than a science fiction scenario. It was technological suicide. I hope this captivating yet equally chilling story has both added new things to your knowledge and left you feeling peacefully sheltered. What other historical adventures shall we embark upon next? Don't forget to let us know in the comments. For now, deep dreams.